Okay, let Sn is equal to 1 plus q square up to q power n, and Tn is given in a similar way, and they have given one condition 101 C1 plus 101 C2 S1 etc. equal to alpha T suffix 100, then what is alpha? Now the first thing is, here we want S1, S2 etc. So this Sn we are going to simplify it. Now if you see, this is a geometric progression. So q by 1 is q, q square by q is q. So we can see that the common ratio is q. So therefore I will write Sn is equal to A into, now the formula is r power n minus 1 divided by r minus 1. This is the formula to find the sum of a geometric progression. Okay, now the value of A is 1 here into r. R, the common ratio is q here, so it is q, and n is the number of terms. Actually the number of terms is n plus 1, because if you look from q power 1 to q power n, so from 1 to n there are n terms and another 1 term is there. So total terms are n plus 1. So it is q power n plus 1 minus 1 divided by r is again q minus 1. Okay, so this is Sn. Now similarly if you see, Tn is also a geometric progression with common ratio q plus 1 by 2. So even this I will combine it using the geometric progression formula. So therefore here Tn is equal to, again it is A, that is 1 into r. R is q plus 1 by 2 power n. Now again this is q plus 1 by 2 power 1, this is 1, this is 2 up to n. So from here to here there are n terms and this 1 term, so totally there are n plus 1 terms, minus 1 divided by q plus 1 by 2 minus 1. Now if you try to simplify this taking LCM, 2 power n plus 1 and 1, so here the LCM is 2 power n plus 1. So this is 1 into this cube plus 1 power n plus 1 minus, this is 2 power n plus 1, when it gets multiplied it will become 2 power n plus 1 divided by, similarly here the LCM is 2, so this is q plus 1 minus 2. Yes, now if you do one step of simplification, this is q plus 1 power n plus 1 minus 2 power n plus 1 divided by, so here 2 cancels with 2 power n plus 1, 2 power n times. So 1, 2 will get cancelled. So this will be 2 power n into, now that will come down also, and q plus 1 minus 2 can be written as q minus 1. Okay. Now if you see here in this condition I need t suffix 100. So this is t suffix n. So now I will put n is equal to 100. Therefore t suffix 100 will be q plus 1 power 101 minus 2 power 101 divided by 2 power this is 100 into q minus 1. So this is what we get. Yes. Okay. So just note that the value of, we want t suffix 100. So if t suffix 100 we want, the value of n should be put as 100. Yeah. Now we will go back to the main question. So therefore now the main question is 101 C1 plus 101 C2 S1 plus 101 C3 S2 plus so on etc. 101 C 101 S100 is equal to alpha into t suffix 100. Now this is the question here. So this is equal, this implies 101 C1 plus 101 C2 into what is S1. Okay. Now if you can calculate S1 from here. If you go to S1, you want to put n equal to 1. We want S1. So, S1 means you have to put n equal to 1. If you put n equal to 1, you will get q square minus 1 by q minus 1. So, q square minus 1 is actually q plus 1 into q minus 1 divided by q minus 1. This will cancel. So, you will get q plus 1. So, S1 is actually q plus 1. Okay. So, actually S1 comes q plus 1. So, it is that plus 101 C3. Now, if S1 is q plus 1, S2 will be the next term added to it. So, it will be 1 plus q square. So, it will be 1 plus q square, and like this going in the same way, finally it is 101 C 101 into what is S 100. So, Sn is up to q power n. So, S 100 should be written till q power 100. So, it will be 1 plus q square, so on up to q power 100. Okay, that is equal to alpha into, now t power t suffix 100 I will just copy from here. So, it is q plus 1 power 101 minus 2 power 101 divided by 2 power 100 into q minus 1. Yes. Okay. Now, what I will do is, this q minus 1 I will cross multiply to the left side. This is on the right side. So, I will cross multiply to the left side. This will imply 101 C1 into q minus 1 plus 101 C2 into, now q minus 1 into q plus 1 becomes q square minus 1 plus 101 C3. This is q minus 1 into q square plus q plus 1. This is a minus b into a square plus ab plus b square, which is a cube minus b cube. So, it will become q cube minus 1. So, you see the pattern which is going q minus 1, q square minus 1, q cube minus 1. Like that, if when this gets multiplied to this term, you will get q power 101 minus 1. Okay. So, you can see the first term has q, the second term has q square, the third term has become 3 cube. So, when this is 3, see when this is 3, it is q cube. So, therefore, similarly if you try to take the idea from that, so this term will become etc. This will become, when this gets multiplied to this, it will become 101 C 101 into q power 101 minus 1. So, same idea, equal to alpha into, so this is alpha into q plus 1 power 101 minus 2 power 101 divided by 2 power 100. This is what you get. Yes. Okay. Now, what I will do is, I will open this bracket and q terms I will collect it together. Okay. So, I will collect q terms together. This implies, okay, so 101 C1 into q plus 101 C2 into q square plus 101 C3 into q cube. Like this, if you go on collecting, this term, last term will become 101 C 101 into q power 100. This is one set of terms which we get, and in other set of terms we have minus 1 common. So, I will write this as minus of, now this minus I have kept out. So, I will get 101 C1 plus 101 C2 plus 101 C3, like that. Finally, I get 101 C 101 equal to, this is alpha into this thing, I will write as it is, q plus 1 power 101 minus 2 power 101 divided by 2 power 100. Yes. Okay. Now we will, okay, this is 101. Now we will look at this carefully. So suppose you try to visualize that carefully. Actually, if you talk about this, suppose you try to expand this, okay, or if you try to expand, suppose you try to expand 1 plus q power 101. This is actually 101 C0, okay, 1 power 101 into q plus 101 C1 1 power 100 into, okay, this is 1 power 101. So next it will be 101 C1 1 power 100 into q plus 101 C2 1 power 99 into q square. This is how the expansion goes. Now if you try to check this expansion, what I have got here, we have the expansion from here. See, 101 C1 q plus 101 C2 q square. So we have the expansion like this, whereas this term is missing, that is, this term is missing here. Actually, if you see, 101 C0 is missing. If 101 C0 was missing, then this whole expansion could have been written as 1 plus q power 101. Okay, now you can't write it because this term is missing. So this term actually is missing here, but we have all the terms from here up to the end. Okay, that means this term we have to add extra. So now in the next step, I will add 101 C0. So this implies I will just add 101 C0 and other things I will write as it is, but later I have to balance it. So next, all these things I will write as it is, like this, and I will write up till here 101 C 101 q power 101. Okay. Now what I have done is, this term I have added extra. 101 C0 is 1, therefore you have to balance by adding minus 1, so that cancels. Okay. Now there is another result in combination. The result is like this: NC1 plus NC2 plus similarly NCN is always 2 power n minus 1. So this is a very important result, and we have it here. See, 101 C1 plus 101 C2 up to 101 C 101. So 101 C1 plus 101 C2 up to 101 C 101. We have this. So therefore the answer of this actually will be 2 power n minus 1, that is 2 power 101 minus 1. So therefore this answer is minus. So this answer according to this is 2 power 101 minus 1 equal to, then this I will write as it is. So it is alpha into q plus 1 power 101 minus 2 power 101 divided by 2 power 100. Okay. So now if you look at this expansion can be written as 1 plus q. Okay, this expansion here is nothing but 1 plus q power 101. Now this is the complete expansion of 1 plus q power 101. Here this minus 1 and this plus 1 cancels, so you will get minus 2 power 101 equal to alpha into q plus 1 power 101 minus 2 power 101 divided by 2 power 100. And if you look at both sides, this is exactly common as this, so this will get cancelled, and when 2 power 100 cross multiplies, you will get alpha is equal to 2 power 100, and hence alpha was the question, so 2 power 100 is the required answer.